In problem number 7, we've got a random card being selected from a deck of cards, and then we're going to do that 40 times. And what we want to know is we're saying that C, our random variable, is the number of clubs we select from the 40 decks of cards. This is a binomial distribution. The number of trials is going to be 40. The probability of success, getting a club, is going to be 0.25. And then I know for binomial distribution, the expected value or the mean is equal to n times p. In this case, 40 times 0.25, that's going to be 10. And then the variance of C or X, I should change this, which makes us make this C here. That's better. The variance of C is equal to n times p times 1 minus p. In this case, it's going to be 10 times 0.75 or 7.5. That's the variance. That's part A. And then in B, they say obtain an approximation. That's a clue that we're going to use a normal distribution. And they want us to justify that. Well, let's go ahead and justify it now. N times P is equal to 10. That's greater than 5. And N times Q, 10 times 0.75 is 30. That's also greater than 5. So that's our justification. We're going to change this to a normal distribution. The mean is going to be 10, and the variance is going to be 7.5. We've got to make the continuity correction with our what we're trying to find the probability of. So the continuity correction, that means the less than or equal to 8, but it's got to include the 8. Now keep in mind, we're only going to use either 8.5 or 7.5. So in this case, we're going to use 8.5. And now I got to use the z-score. I'm going to do 8.5 minus 10 divided by square root of 7.5. I'm going to get a z-score of negative 0.548. And then I'm going to rewrite this now. I'm trying to find the probability that z is less than or equal to negative 0.548. Well, I'm happy that it's less than, but the problem is it's a negative z-score. And what I've got to do is kind of rewrite it in a way so I'm using a positive z-score. And if I do the positive 0.548, that's going to be above that. So actually, this is going to be equal to 1 minus the probability of z being less than positive 0.548. And then when I figure that out, I plug it into the calculator. I get this right here. I do 1 minus it, and I get the probability as being 0.292. That's all there is for that one. On problem number 8, we've got 55% of the people questioned are full-time employed. In a random sample of 80, we've got to find this stuff. So the probability of success being employed is 0.55, and the number of trials is 80, because we asked 80 people. The expected value, this is a binomial distribution with 80 trials and a probability of success of 0.55. The expected value or the mean is going to be n times p, or 80 times 0.55, which is going to equal 44. And then the standard deviation, well, the variance of x, that's going to be n times p times 1 minus p, or 44 times 0.45, which is going to be 19.8. Now the standard deviation is going to be the square root of the variance. So the standard deviation is going to be the square root of 19.8 or 4 point blah, 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 which is going to round to 4.45. Now, in part C, they want us to approximate the probability that fewer than half of the sample are full-time employed. So fewer or approximate, we're probably going to use a normal distribution. Now, we want to find the probability that x is less than 40. If we write this as a normal distribution, well, our mean is going to be 44, and our variance is going to be 19.8. And we've got to rewrite our probability statement. We could make the continuity correction. So it's less than 40. It doesn't include 40. So we're going to pick 39.5. Keep in mind, when you're doing this approximation, it's always going to be 0.5 above or 0.5 below. Anyway, we're going to do 39.5 minus 44 over the square root of 19.8 to find our z-score. Our z-score is going to be 1.011, a negative 1.011. And when we do a quick sketch of that, we realize that, well, it's easy to see it's negative. and we're less than that. So what we want to do is rewrite this probability statement so it's less than a positive number. And the way to do that is we're going to do 1 minus the probability that z is less than 1.011. They're going to be the same shape. So now that's going to give me 1 minus 0.8439917, which is going to be a probability of 0.156. Now that's all there is for that one.